Hi everyone, this is the last section of Unit 3, Complex Numbers, and the key concept here is to be able to express radicals with even indexes or indices with an even index. That'll help me out there. To be able to express radicals with an even index when the radicand is negative. Okay, so go ahead and pause the video if you need a couple of seconds to write all that down. I'm going to talk about what a radicand is and how we're going to handle this when it happens to be a negative number. So before, if we were to do, let's say, go back to our square root of 25. If we were trying to find the square root of 25, the index here is even, it's a 2, okay? That means you were trying to find two numbers that were identical, and they have to be totally identical, meaning they have to have the same sign, and that will multiply to 25. So these two numbers happen to be 5 and 5, so therefore the square root of 25 is 5. No problem there. And then if we had, let's say that we had the square root of 16, and you're trying to find two numbers that are identical that multiply to 16, well, 4 and 4 works, so the square root of 16 is 4. So the problem here is, what about when we have the square root of negative 25? So the negative 25, that's the number under the radical. That's called the radicand. The radicand is the number under the radical. And so it's still a square root, so you're still trying to find two numbers that are identical that multiply together and give you negative 25. Well, people might say, well, how about negative 5 and positive 5? Well, I agree that those two definitely multiply to negative 25, but they're not identical. This one's got a negative, this one doesn't. So that doesn't work. They have to be identical. Got to have the same sign. Well, how about negative 5 times negative 5? Now they're identical, but when you multiply these two, you get positive 25. We don't get negative 25. And so there really is no way to figure out a square root when you have a negative number under the radicand. It's not possible. In fact, under the real numbers, which are the ones that you've been studying since you learned how to count, that's what your calculator is programmed to use, the real numbers. So if you try to put the square root of negative 25 in your calculator, it has no idea what to do. It says error, non-real answers. That means that your answer is something other than a number in the real number system that you've learned ever since you learned how to count. So I'm going to show you how to express those answers even though it comes up as an error. So mathematicians have come up with a way to express these answers. So they came up with a label, and they said, all right, so if it's got to be a non-real number, it must have to be an imaginary number. So an imaginary number starts with the letter I, so they decided to use little lowercase I to represent when we have a negative number underneath a square root or a fourth root or a sixth root or anything that has an even number in the check mark. And so this little I right here is a label for every time we have the square root of negative 1. Negative 1 is the smallest number that we could take the square root of. That's an integer. And so this is the label that they gave for the square root of negative 1. So that tells the reader, whoever sees this little I, that means there must have been a negative under the square root. So basically, the rule is every time that you're just
going to have an I in your answer. Okay, so watch how we do this with that 25. So this will be the square root of negative 25. We know from multiplying that we can break this down to the square root of negative 1 times the square root of positive 25. If I multiply these together, I get negative 25. Well, our new rule is every time we have this, we write down a little I, and then we do the square root of 25 like we normally would. And we know the square root of 25 is going to be 5. So our answer is I, little cursive I, times 5, or we can write it like this using the commutative property. And this is how you would see it on a standardized test. So the negative goes away, it becomes an I, and then you break down the number like you normally would. So let's go through this one. First example. So this is what I tell everybody to do just to make this really simple. Whenever you have a square root or any even index and you have a negative under here, just cross this out and write a little I down here. Okay, that takes care of that negative. You're not going to have a negative answer. Okay, your answer is just going to have a little I in it. That negative is going to go away. So you break this down, 5 times 5, and then these are prime, and then you have x times x. So we have a group of 2 here, 5, and you have a group of 2 here, x. And so your answer is 5ix, or you could write it like this, 5xi, or you can really write it in any order you want to because the commutative property allows that. But these would be the two popular choices for a standardized test. And that's it. You're done. So try this one. You have the square root of negative 225. So I've got a negative underneath a square root. So that means I'm going to cross this out and I'm just going to put a little I down here. That takes care of that negative under the square root. Now break down 225. 5, let's see, what is 225 divided by 5? 5 and 45. And then 5 times 9, and then 3 times 3. So we're doing groups of 2. 3 times 5 is 15. You've got all these z's. So here's a group of 2, here's a group of 2. So z squared. And then it looks like you have a z left over. So a z under the radical. So this will be 15 z squared I root z. Okay, notice my answer is not negative. It just has an I in it. The negative goes away, becomes an I. Try the next one. You're taking the square root of a negative 150. So cross this out, put a little I down here. So 150 is 3 times 50. 50 is 2 times 25. 25 is 5 times 5. So, and then you have all these p's. Okay, so we can take a 5 out. And let's see, I can't take anything else. I can take the p's, 1, 2, 3, 4, 5. So p to the 5th, square root, you got a 2 and a 3 left over, so square root of 6. So your answer is 5p to the 5th I square root of 6. There's your answer for that one. I'm going to box these other ones too. Okay, let's try the next example. Square root of a negative number. So you're going to have a little I in your answer. 228 is 2 and 114. And then we can do 2 and 57. And I think that's as far as we can go with that one. I believe 57 is prime. Okay, so that's it with that one. And then you're going to have 1, 2, 3, 4, 5 x's. 1, 2, 3, 4, 5, 6, 7 y's. So I can take a 2 out.
and then group of 2, here, here, and here. So x squared y to the third, and then square root of xy. Oh, and I had a 57 under there too. So 57. So let me clean this up. This will be 2x squared y cubed I square root of 57xy. Okay. Okay. So the last two here are negative under the root, but excuse me, this is not a square root, it's a cube root. So this is a whole different story. When you have a negative underneath an odd index, then your answer is just negative. There is no I for this one, okay? All you want to do is just pull the negative out. And so why is that? Well, let's go with like a really basic example. Like let's say we had the cube root of negative 27. Okay, this is not on your sheet. This is just me making something up. A cube root means that you're trying to find 3 of the same thing and that they're identical to each other. And they'll all multiply to negative 27. Since we have 3 of something, I can have a negative answer. Because watch how this happens. A negative times a negative is positive. A positive times a negative is negative. So this actually works out. It didn't work out with the square root because we only had 2 numbers that we could use. But if you have an odd number, you could have that negative under the radicand because it's going to give you a negative number. So this just happens to be 3, right? Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So your answer is negative 3. So that's why every time you see a negative under a cube root, all you have to do is pull the negative out. And the same thing for this 5th root. All you're going to do is just pull the negative out and it'll be part of your answer. So this one will not have an I either. No I for this one either. So then you break down your 64. I'm going to go ahead and do that one. It's going to be 4. If you remember that from when we did our sum and difference of 2 cubes, cube root of 64 is 4. Cube root of x cubed is x. So that's your answer for that example. For 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2, and we happen to be doing groups of 5, and I have 5 2's, so 1 2 comes out, and then the x squared has to stay underneath. So your answer would be negative 2 5th root of x squared. The 5 also is odd, so you're going to have a negative under the radicand. That's absolutely fine. You can have, you'll then have another negative as your answer. Try a few of the practice problems on the homework. See if you have any questions.